Hello, everyone, and welcome to our SANS webcast, emulating and preventing SMB attacks, including relaying and responding. My name is Randall Jones. I'm the Offensive Operations Marketing Manager here at SANS, and I will be moderating today's webcast. Our featured speaker today is Michel Coene. Michel is one of our Security 599 instructors, also based over in Europe. So he does a lot of his course runs over there. He has some coming up. If you're not familiar with Michel, he has his instructor profile page up to view other information about him. And also, Michel actually did a recent webcast for us featuring other content from Security 599, which was on common persistence strategies. So if you didn't watch that, I'll go ahead and drop the link in the chat after we get started here. If you have any questions for Michel during the webcast, please enter them into the Q&A window at any time. We have quite a lot of content to get through today, so please do enter them as we go, and Michel will be coming back towards the end or during the presentation to answer those. Please note that our webcast is being recorded and will be available for viewing later in your SANS account under my webcast. And with that, take it away, Michel.
All right, thank you, Randall. So, hello everyone, and thanks for joining this talk on emulation and prevention of SMB attacks. So, as Randall mentioned, I'm Michel Coene. I'm an instructor for SANS. I'm teaching the SEC599 course, which is the Defeating Advanced Adversaries, Purple Team Tactics, and Kill Chain Defenses course. So it's a purple teaming. In addition to that, I'm the head of incident response and threat intelligence at Enviso, where I lead a team of, and you'll be surprised by that, incident responders and intelligence analysts. Yes, absolutely. And of course, I'm lucky to also be allowed to still do some or a lot, depending on how you look at it, hands-on work there as well, so that I can enjoy investigating attacks as the ones that we will be discussing here today. Now, I do understand that you might be anxiously waiting to say, let's dive into those attacks and see what that SMB type of attack looks like, how we can investigate it and what we can do about it. But we first have to start with a small introduction on NTLM v2 authentication. Yes, indeed. To understand these SMB relaying attacks or SMB attacks in general, we will need to look at NTLM v2 authentication. Below here on the slide, we have a common setup for within a Windows domain environment on how NTLM authentication actually works. So let's just run through this for a second. We have a client workstation. It's one of the three parties who's typically involved. The client workstation, client that wants to authenticate to a specific service. In this case, this will be the database server service, right? The database server service is the thing we want to get access to. That one in itself will likely not know your credentials, so we will need to be able to validate the authentication, and that's something where the domain controller plays its role. So we also have our domain controller that plays a big role in our authentication. How does this work exactly? Well, we have a client that says, I would like to authenticate to the database server service. So the first thing that we do here is send an authentication request. So this is a negotiate package that contains some parameters like the version of NTLM, inform the server, okay, what is this client capable of, those types of things. This is sent to the service that we want to authenticate. This service will say, okay, sure, you want to authenticate, fine, here is a challenge. And based on that challenge, you need to calculate a response. Now, this challenge that is sent here contains a 16-byte nonce. It's called the nonce. So this is a 16-byte random number, right? Based on that number and some other inputs, we'll see about those exact inputs on the next slide, a response is calculated. Now, very important, one of those inputs is the client password hash. So the client password hash is used together with that nonce to calculate the response, which is then sent back to the database server service. In order to validate that, certain calculations need to be made also based on your username, password, and other information, and the nonce, of course, the challenge that was sent. Now, the database service typically does not know your password or your password hash, so the validation of your response is done by the domain controller. So the database service will forward both the challenge that it sent in step 2 and the response that it got from the client, will forward that to the domain controller. Based on that information, the domain controller itself can do the validation to see, okay, is somebody or is the client actually who he or she says he is? So that's the validation part there. Does the calculation work out, or is a wrong password used and the validation does not work? Based on that feedback, the database service can then say, okay, authentication is granted or denied. So what's nice about this flow is that within the entirety of the flow, the exact password hash is never sent between two systems. So we can authenticate to a certain service without having to send over our password. Right. What does the exact calculation look like now for generating that response? Well, first we got our challenge from our service. Challenge, the 16-byte random value, random numbers, 16-byte nonce. The first step that we do is we take our account password hash and use it as a key in an HMAC MD5 together with our username and domain name. The output of that is the NTLM v2 one-way function. That NTLM v2 one-way function is then used in its turn as an input for another HMAC MD5 together with the challenge that we received here from the service, timestamp, and some other values there. The output of that HMAC MD5 is then the NTLM v2 response, which is sent back to the service itself. So important to keep this authentication flow, or this calculation flow rather, keep that in mind when we're talking or when we start talking about the attacks, because this will also make it very clear why both the challenge and the response are so important to capture by attackers to then do their follow-up attacks, which we'll talk about in just a little bit. Now, you might be sitting there and thinking, Michel, why are you talking about NTLM v2? It's 2022, right? Everything in our environment is Kerberos, correct? Kerberos is the default authentication mechanism within Windows environment. Absolutely. Is this the only authentication mechanism? No, it is not. There's a few things that we need to think about when thinking about, okay, authentications within our Windows environment. First of all, Kerberos, definitely the default authentication mechanism, but the Kerberos by default relies on service principal names to do authentication. So by default, this means that whenever an IP address is used, so when you go into your Explorer window, type in / / 192 or 168.10.10, Kerberos will not function. The system will use the just shown NTLM authentication to authenticate to that remote system, to authenticate to that network share on the remote system. It is indeed possible to change this and to also use Kerberos for that. By default, Kerberos does not really like IP addresses, but you can change it using your group policies to also use IP addresses with Kerberos there. A second and probably more important reason why NTLM v2 is still used is older software. Yes, I'm going to say it, legacy environments, legacy software, legacy systems. There's a lot of systems, a lot of software within your environment, very likely, that does not support Kerberos. And that relies on NTLM v2 to perform its authentication. This can be just any application that you have self-developed or third-party developed, can be a non-Windows system that does not support Kerberos yet, or that, well, is so old that it doesn't support Kerberos yet, or anything else. But have a look at your environment and see, are there any systems that do not support Kerberos just yet? If that's the case, very likely you will have to keep using NTLM v2 or keep allowing NTLM v2 as an authentication mechanism within your environment itself. There are a few environments that I've seen that have fully disabled NTLM v2, but those are more environments like with startups or environments that are very recently built, so that don't have any legacy system. However, these are still the minority these days. If you probably think about your own environment, you'll see that yes, we still have a lot of older systems, probably systems running there that you have no clue what they're doing, but everybody's too afraid to turn them off, of course. Good. So we have now that introduction. Let's now start looking at our different attack strategies. How can we get that NTLM v2 challenge response? That's the main thing that we need to ask ourselves, right? We want to get that NTLM v2 challenge and response. We want to get that hash so that we can use it in subsequent attacks. That also means that we would need to have someone authenticate to us, to our machine, meaning that we want to lure someone in various ways. We'll talk about some different ways. We also have some nice demos prepared on that. We want to lure someone to try to do NTLM v2 authentication against our machine so that we have control over that nonce that is being sent, that we know the nonce that is being sent, and that we also can capture the response so that we can then do further actions on those. In order to do that, to get those NTLM v2 challenge responses, there's a nice tool out there called Responder. A Responder was initially developed by Spider Labs, by Laurent Gaffy, and is really focused on attacking NTLM authentication. So how is Responder taking care of the fact that we want people to authenticate to us? Well, it's using two multicast protocols, or it's at least abusing two multicast protocols. MBTNS, so NetBIOS name server, and LLMNR, Link Local Multicast Name Resolution, which is the more modern version of MBTNS. So what are these protocols used for? When you have a system in your environment, let's say my system, and I want to connect to the machine Windows 02, because I know there's a machine Windows 02 in my environment, but I just mistype and I type in Windows 03. Now there's no Windows 03 machine within my environment, meaning that I will not be able to connect to that machine. What will my host do in a first stage? It will say, I will send out a DNS request. Okay, what's the IP address of Windows 03? DNS server will say, I will not respond, will say, look, I have no clue, Windows 03 does not exist. Now my machine will not be satisfied with that. It will also send multicast messages, so NBTNS and LLMNR messages on the subnet, on the broadcast domain, saying who is Windows 03. So it's a bit like an ARP feature for hostname resolution. So indeed, like it says here, what could possibly go wrong with this? So it's just sending out a broadcast message, who has this hostname? What the responder will do, and we see that here on the next slide, it will listen on all of those messages. And when it sees a host name that is not within your DNS records, that cannot be resolved, it will reply, look, it is me. You can connect to me. So it will send back the IP address of the host that is running Responder. We see it here within the slide on the screen. We have here the listener for events, the Responder listener for events. Somebody is requesting the host name Erik Fabu. It doesn't exist, so we will send a poisoned answer to this IP address. This is the host. We'll send, okay, this is us. We have the IP address. This is my IP address. I'm Erik Fabu, so you can authenticate to me, capturing that NTLM v2 hash, which we see here. And this hash we can then later use. We'll come back to that on how we can use that exactly. That's one way. Another interesting way of capturing that NTLM v2 challenge hash is by abusing some other functionality of your Windows system. And that is when somebody tries to go online, tries to use their browser. By default, in the majority of browsers, you have something called the auto-detect proxy settings. What will that do? When the browser is started, it will look for a proxy within the environment. And by default, a proxy within the environment can be found by using the WPAD .internal domain name DNS record. That is the thing, or that's the record that says, this is the proxy that you should be using. Now, just like before, when I mistype my Windows 02 into Windows 03, we also have responder that will respond to the WPAD request, MBTNS LLMNR request. Now, this is a bit more than just capturing that NTLM v2 challenge response. Because if we can say with responder, yes, I have the IP address, or I am the proxy, you need to connect to me, we can do an effective meddler in the middle type of attack and redirect all of the traffic, all of the internet traffic over our responder host and do the interception there as if we are an actual web proxy there. So pretty interesting. Optionally, we can also configure responder to force NTLM authentication so that we also capture the credentials as well. There's, of course, a lot more creative ways of getting that NTLM v2 challenge response. This is described by lots of security researchers, also used by lots of different attackers. We've seen quite a few of these attacks being used in the wild, being used by attackers within organizations. One very interesting one is vulnerability scanners running authenticated scans. So when you as an attacker are already inside the network, be it on a device, with a device that you plugged into the network, or just you have access to a machine, and you can, for example, set up a listening port on that machine itself and just keep on listening until the vulnerability scanner comes around. Right, that vulnerability scanner running NTLM, running with elevated privileges, or at least high privileges, will just start checking all the open ports and will try to authenticate if you request for authentication. So that way you can capture the NTLM v2 challenge response from a highly privileged account, which is typically what our vulnerability scanners are running with. Another one is embedding a remote picture in a Word document. We actually have a demo on that, so I won't go too much in detail on this one. We have a very nice demo prepared for this one. Some other ones, embedding a remote icon hosted on an SMB share in a folder share, or adding an SMB share to an image, embedding an SMB share to an image in web application source code. So all of this, all those last three, there you just say, open a remote image, or at least load a remote image from a remote source. So from an SMB server on the internet. Now what will happen there with the Word document, with all the other examples as well, you will have the icon, your Windows machine will try to load it through single sign-on, it will try to authenticate to that SMB server, which is on the internet. What will in effect happen? Remember that NTLM v2 challenge response, that hash will be sent out to the internet. So definitely already something to say here is to disable outbound SMB due to this. It was a few years ago that we all of a sudden saw a huge uptick in these types of things, where we saw a huge uptick in those remote pictures being hosted in Word documents, for example, where lots of credentials were potentially stolen or likely stolen through this. Now I say credentials stolen, of course, we know that we have the hash. Now with that hash in itself, it's not that we can do a pass the hash attack purely with that NTLM v2 hash. We need to do something extra with this. One of the things we can do is try to crack that hash using a tool, for example, Hashcat. So Hashcat does have built-in support to run a dictionary or brute force attack against NTLM v2 challenge responses using the option 5600. So as we remember what the output looked like from responder, this is the NTLM v2 challenge response, all nicely together with the username in here as well. We provide this to hashcat within a text file. We provide a password list and then an output crack.txt, and we let it run until we can try to crack the password in itself. Let us now take a look here and see how this all works. So here we are going to demonstrate an NTLM v2 sniffing attack. So what we have here is a Windows 02 machine, standard Windows 10 machine, and a Kali host, which are on the same subnet. So this is our Windows 02. We will see that we can connect to certain machines, but we'll also show that other machines are non-existent within this environment. So first we're going to have a ping to our Windows 01, which is another machine in this environment, 10.15. We're going to do the same to Windows 02. This is the current machine that we are working from, 10.16. And then we're going to try to ping the Windows 03. And we see that we're not getting any replies, meaning that Windows 03, it does not exist within our environment. Okay, so the first step that we need to do to capture those LLMNR requests or MBTNS requests and eventually capture those NTLM v2 password hashes is start responder. Now, in order to start the responder, we need to provide it with an interface that the responder will be listening to. So looking at our interfaces, we see that we have ETH1 here. So that's what we can provide. So ETH1, it's running on the 192.168.10.55. So that's the interface that we will be using to listen to those broadcast messages themselves. There's also a few other options that you can use within the responder. Here we'll just use the verbose option. Voila. So right now, responder is running on our system. There we go. So with responder, the first thing that we see here is that we have a number of poisoners running. So the things that are listening. So we have one for LLMNR, we have one for MBTNS and for DNS there. In addition to that, we also have a number of servers that are running. So those servers, they are on. However, it's important to note that these servers, while they are on, that it doesn't mean that they are actually listening on those servers. We see it here at our starting TCP server on port 80. That's because Apache's tools is apparently already running on this machine. So we will not have the HTTP server running. Not a big deal. It's not what we're using at this point in time. That's for a later demo here. All right. Let's start the Wireshark network capture so we can show that in just a little bit as well. And then go back to our Windows 02. So remember the Windows 03 that we tried to ping earlier that didn't work because it wasn't present in our network. When we try it now again with responder running, we do see that we get a reply. And remember what the IP address of our Kali machine was? Indeed, it was the 10.55. So our responder has indeed sent a poisoned answer for that Windows 03 host, which doesn't actually exist within our environment. So we now we can send pings to that Windows 03 because we got the poisoned answer through our LLMNR and MBTNS requests. This is also something that we will be able to see within our Wireshark here. So looking at Wireshark and searching for those LLMNR captures. Here we need to enlarge this a bit to make it a bit more clear. And we'll have to stop our Wireshark capture as well. So we can now go up and start looking for those LLMNR and LLMNR poisoning. So the first thing we saw already was who has Windows 03. So you see it there, a standard query for record Windows 03. That's the request that was being sent through LLMNR. And there we, with we, I mean our responder tool, of course, sent back a response that, yeah, we are Windows 03, and this is the IP address that you can connect to. So really nicely showing that LLMNR, well, poisoning. I'll put it like that because it's called a poisoner within our responder as well. Good. So now we know that this is working. We're already poisoning our LLMNR requests. Now let's take a look at how our NTLM v2 hashes can be captured by also replying to those SMB requests. So what we will be doing on our Windows 02 machine is we will open a share to the Windows 03 machine that does not exist. Well, the Windows 03 machine in itself does not exist. So the share won't exist either. So we know that our responder is listening to all of that information and that it will try to redirect us to that 10.55 host and will start requesting authentication there. Interesting to see as well is while we start typing for Windows, that it does some discovery, network discovery already, which we also see popping up in our responder field. So then when typing in Windows 03 / Windows 03, we immediately see two authentication attempts for Alan Marshall. Alan Marshall is the user that is authenticated on our machine. Now, this is all done through single sign-on, so there's no user interaction required there. What we also try to do here is just try to log on as a user with the username user and the password test and test2 for demonstration purposes here. So we stop the Wireshark capture. We'll look at that in a second. So looking at our responder, we very nicely see that everything that we envisioned very nicely worked and that we actually captured those challenge responses for both Alan Marshall and the user. And this is also what we will see in our Wireshark captures here. Looking at SMB traffic. Voila. We see some first authentication as the user Alan Marshall. All right, says cool. Need some more information. Try to authenticate as Alan Marshall again. So it's talking SMB and saying, look, we don't have sufficient information. Try to authenticate as Alan Marshall again. Then we will say, yes, okay, this didn't work. Access is denied for the user Alan Marshall. Please enter some other credentials if you want to get access to this host, to this machine there. And that is exactly what we have done there. We used the account of user where we entered some bogus credentials. They also said access is denied, after which we tried again a second time with the user, captured those hashes as well. And then we canceled the flow ourselves in a bit later. So again, after we got that access denied there. Now we have those hashes. What can we do with those hashes? As we've seen during the slides, we can use a tool like John the Ripper to crack the hashes, those NTLM v2 challenge responses. Now, in order to do so, we need to copy the output of responder into a file. And we will need to do some cleanup on all of this, because we only want to keep everything that starts with Alan, Marshall, or user. That's all we want to keep there. Need to do a little bit of cleanup so that it's within the format that John the Ripper can actually use there. So inserting this into a file, and then we're gonna do just a little bit of cleaning up. Only keeping the lines that have hash in it. Now we just need to go into the file and remove the initial portion there, so that we only keep Alan, Marshall, and the rest, and then user and the rest. This will then be run through John, the tool John. And of course, as I just mentioned, for demo purposes, we use some simple passwords, test and test2. These passwords are in the default password list. The password of Alan Marshall itself is a bit more complex, so it doesn't show up here immediately. You might be able to brute force that one. But with this, we already have a few credentials that we could try using there. All right. So that was our first demonstration showing how to get that initial NTLM v2 challenge response, and we could then nicely crack those challenge responses as well. Let us now immediately jump into a second demo. With Responder, we can also capture the NTLM v2 challenge responses when someone tries to authenticate to a WebDAV server. Now, first thing we need to do, and we saw that during the previous demo, because port 80 was in use, we need to stop Apache. We want the Responder to listen on port 80, of course. So Apache needs to be stopped. Then we're going to start our Responder. We know our interface is Ethernet 1, and we put the verbose mode on again. Starting this, we indeed see that port 80 is now, there's no error on port 80, and that we can use that one. Now, important here, because we want to simulate those two machines are on the same network, but we want to simulate that some host is communicating outbound and not over the network. We have put in place some firewall rules to block port 143 and 445, just for demo purposes, that we really want to force our machine to connect over HTTP there. All right. So now let's make a WebDAV request, and we can do that by using the netuse command, star for any drive letter, and connect to our Kali host, HTTP ://192.168.10.55, and we provide it with a user and a password, a user DTA and password test in this case. On Kali, let's also restart our Wireshark so we can nicely capture those packets as well, so we can then come back and see how we are doing. So we have a Responder running, and we are ready to start our WebDAV. And clicking enter here. And then indeed, we see that Responder has gotten an HTTP authentication request. And that for that request, we have captured the NTLM v2 hash as well. With this, we can now, with this hash, we can now do exactly the same as we've seen in the previous demo. Looking at this traffic and Wireshark, we'll filter on HTTP because it's HTTP traffic. Here we see an options request first, followed by prop find request, and then other ones with the authentication saying it's unauthorized there as well. So to show the WebDAV usage here, we can see indeed that the user agent used is Microsoft WebDAV mini redirect agent. Voila, there as well, also with the prop find. So the responder will reply with the message unauthorized, saying it requires authentication, after which the user, or well, your host, tries to authenticate to that host itself. And with that, then your NTLM v2 challenge response is captured and can be cracked. So you see the NTLM authorization there in the web request. So pretty nifty. So you see that we did that for the user DTA, the one that we provided on our command line, of course. Now we can make it a bit easier on ourselves, because here the attacker or the user needed to either make a typo somewhere, you type in Windows 03 instead of 02, or needed to do a WebDAV request somewhere. We could do that through social engineering, something else, but we can make it a bit easier on ourselves. And this is an attack that we've seen, as I mentioned a few years ago, quite extensively being used. This is also one of the attacks that we highlighted earlier. This is using a malicious Word document without, this is important, without macros. So I'll just show you a few screenshots before we jump into this exact demo as well. But what we're going to do is open a new Word document, press F9, and then type in import an image. So we're going to import an image from a remote source. This image, we're going to say, look at field properties and say the data is not stored within this document, meaning it will reach out to our remote server to attempt to fetch the image that we have included or that we have referenced. Now, small spoiler here, we're not actually hosting an image. We're just using the responder functionality to have that machine that's opening this Word document, to have that machine authenticate to us via single sign-on. Let's see how this actually works in the third demo of this one. So here we have a Word document, or at least we have Word open, and we're going to create a new blank Word document without, we're not going to use any macros in this one. Just press F9, and then we're going to type import and // where we want to go. However, for this import, you need to backslash your backslash, so you need to do it double every time. You need to escape your backslash pretty much. So // and then we're going to refer to the host that we have running. This is our Kali host in this example, and refer to a specific image. As I mentioned, this image is not going to be there. Yeah. So now we're going to right click, select edit field, and then say this data not stored with document, so that it actually reaches out to the external source to download the data. Now at this point in time, we don't have our responder running just yet. So our Word was hanging a little bit because it was trying to fetch the data for a machine or something that did not really respond, so it's not really fetching anything at this phase. So we can now save it to our machine so that we can close this, save it to the desktop, call it doc1, voila, and we're going to close this. Okay, now we can go to our Kali machine, and on our Kali machine we are going to start our responder. As we know, responder, we need to provide it with an interface. So in this one's interface ETH0, and we're going to run it in a verbose mode, and we see the information that it is running. So all good on this one. So now we're going to open the document, and what we will see here when the document gets opened is that it will automatically attempt to load the image, and that's also what it shows in our responder. So this is your host, your Word document, pretty much trying to reach out to the remote source, trying to get that image, and it is trying to authenticate using the NTLM authentication for the user that's currently logged on. So you're running Word within the security context of test user 1, those credentials will be used to try to do the NTLM v2 challenge response, to try to do that NTLM authentication. So this is something that we saw attackers use quite extensively in the past year, and can still be used in many organizations, likely still to this day, if you don't, for example, if you don't block outbound SMB connections. Let us now take a look at our SMB relaying, because in this case, in all the cases that we talked about, we indeed had some very nice options to capture those hashes, that NTLM hash. But to use this, we indeed need to capture it. Now, what if we just want to use somebody authenticating to us as the attacker? What if we want to use that authentication to just relay this authentication so that we can get access to the server that we actually want? So how does this work exactly? Well, we have three parties here. Well, there's actually a fourth party, which would be in the domain environment or domain controller. But for simplicity's sake, we just forget about that one for a second. But we have our victim workstation that is authenticating to the attacker workstation. So all of this, all of the left-hand side things, is exactly what we talked about before. It's like having victim authenticate to us and do the challenge response with us as an attacker. But rather than just capturing the password hash or the NTLM v2 hash, we will now forward that request for authentication to a system that we want to get access to a target server. So our victim will request authentication, wants to authenticate to us via either way, via any way that we talked about. We will just say, okay, we're going to forward this request for authentication to this specific database server we want to have access to. What this one will do is say, okay, you want to access me, here's your challenge, 16-byte nonce. Great, what we're going to do is just forward that challenge back to the victim. The victim is then going to calculate the response based on the challenge that it received, the account password hash, the timestamp, some other information there as well, and send that response back to the attacker workstation. Now, rather than capturing all of this here, all of this will just be forwarded to the target workstation. If the victim has the right privileges to access that target workstation, we will now be granted authentication here. And this is where we will stop the flow in forwarding back to the victim, because we will now say, nice, we have access. We will start interacting with the target server. I will just close out the flow with the victim workstation and say authentication failed. As we know, 1 + 1 is 3. So we can enhance this and have people authenticate to us automatically using responder there, using that listening for NBTNS or LLMNR multicast messages. A very nice thing here, and I already mentioned it, but think about those vulnerability scanners that come around from time to time. They typically, as I mentioned, have elevated privileges on machines within your environment. So for an attacker, if you want to do lateral move and you have initial access on a workstation, this is an excellent strategy. So you are an attacker, you have access to a certain workstation, just a compromised workstation where you have an initial foothold, you set up a listening port, and if this would be your vulnerability scanner would scan your listening port here, and you could just relay that authentication to your target system, thereby initiating lateral movement. So definitely we've seen this in a couple of cases, incident response cases that we works apparently very well for the attackers. So definitely a good one to keep in the back of your mind. Now let's see all of this in practice. Let's demo this NTLM v2 relaying attack. So just like in the previous demos, we once again have our Windows 02 machine and our Kali machine. First thing that we're going to do is to scan the network with responder run finger. So if you look at responder, there's a number of different tools that we have there. So the first one is run finger, and there we're going to see, okay, what devices are available on our network that we could use to do relay. When we look at the 10.0/24 network, we see we have two machines, Windows 02, this is the machine that we use as a victim, and the Windows 01 machine, which is the machine that we will be using to relay our authentication towards. Okay. On those machines, you'll see that SMB signing is set to false. So SMB signing is not enabled, and that's an important one when we talk about the defenses just after this demo. We also scan the 192.168.5 subnet, and there we see that we have our domain controller, which has SMB signing set to true. The domain controllers by default do SMB signing, and as such are not vulnerable to this type of attack. Let's now prepare for the attack itself. And for the attack, we need to have two tools running. We need to have responder running, obviously, but we also need to have our multi-relay running there. So looking at the responder tools that are available, there's quite a few of those available actually. And we see here that we have multi-relay.py. So we will first start multi-relay, as this one is going to intercept our SMB traffic. So on port 445. This tool has to run first because it needs to attach to port 445. If you would run responder first, this one would use port 445 to listen for credentials, and multi-relay would not do anything. So we're going to say, listen to port multi-relay. We're going to set the target to the .15, which is the Windows 01. -U is for the user. What user do we want to intercept? And we're just going to say all users. You could also say we're just going to intercept if somebody is authenticating with a certain admin user. That you know this admin user or this vulnerability scanner user has access to our other system. So we're only going to relay those credentials, so not to get failed authentications. When we now run responder, as we see here on the screen, we get another error saying our port 445 is already in use, as was expected, of course. All right. On our Windows machine, we are authenticated as the user Alan Marshall ADM, so the administrator user. We need to have an administrative user that has the rights, that has the privileges to also authenticate to the machine that we want to relay to, right? So we're going to run the attack within an elevated prompt as alanmarshall.adm. And now we're going to connect to a machine that does not exist within our environment. So Windows 05, and this is where responder comes into play, saying, okay, Windows 05, yes, that's me, you can connect to me. We're going to try to authenticate to an admin share, try to access the share for the C drive. When we press enter, we immediately see something's happening within multi-relay. We see here that indeed this session very quickly was relayed to our Windows 01 machine. And we can see that because we have an interactive session with that machine now, where we're using that Alan Marshall ADM password hashes to identify ourselves. And we see that indeed the commands that we're sending is to Windows 01. We can look at the user that we're running under, which is the system user. And we can also run other commands like a directory listing, which will show that we are within the system, Windows System 32 directory. You see all the files there. So all of this happens by relaying the hashes of alanmarshall.adm to the Windows 1 machine. So pretty nifty attack. We don't need to crack any hashes here, but very nice because, well, we get access to a remote machine, can do very nice lateral movement this way. So works pretty good. How can we now defend against these types of attack? Now, first of all, in order to prevent these responder type of attacks that, well, lure your victims, the victims who are mistyping host names or anything else, is to make sure that both NBTNS and LLMNR, that they are disabled. Those multicast messages, that they are not being sent. If you're looking at your office network, do you really need MBTNS or LLMNR? So that multicast message to ask, does this machine exist? Probably not. I would even advise against it. Talking about your home environment, your home setup, probably a different story. You probably, well, maybe some of you do, but the majority of just overall users do not have a DNS server specifically running at home. So there it does make sense. Within a corporate environment, it doesn't really make sense. So that's something we can disable using group policies. Looking at SMB signing, I just highlighted that during the previous demonstration. SMB signing will prevent NTLM relaying attacks. So by default, this is only enabled on your Windows domain controllers, but you can also enable this on other machines using group policies. Do be careful about that. I'm not saying it's going to break something. I'm just saying it can potentially break something. If we're again talking about your legacy systems that are not supporting SMB signing, it can break certain things. So do make sure that you properly test all of this before you put this in production. Make sure that your tools, your systems that they can use, that they can operate with SMB signing there. Talking about our WPAD DNS entry, make sure that it's created. If you have a proxy, if you don't have a proxy within your environment, you can also consider disabling those auto-detect proxy settings within the browser. You have ADMX templates for group policies for all major browsers, where you can secure or harden your browsers and also say, we're going to disable the auto-detect proxy settings. And then finally, if we're looking from an architectural point of view, you want to make those broadcast domains or system-to-system connectivity or talking, you want to make that as small as possible. One idea you could look into are private VLANs. So this would definitely hinder responder in its bidding. Additionally, you probably also want to block SMB connectivity towards external hosts, or even between workstation to workstation. Do you really need SMB connectivity between two workstations within your environment? Very likely not. So if you enjoyed this webcast and you enjoy balance of getting an understanding of how an attack works and then seeing how you can put in place some defenses, this is exactly what we're doing during our purple teaming courses 599 and 699. So if you already did the 504, the 599 is different, definitely a natural progression from that one, and the 699 is a natural progression from the 599. In both courses, we talk about attacks, defenses, detections, and are very hands-on. As you can see, definitely 50% hands-on for the 599 course, 60% hands-on labs for the 699 course. So if you enjoyed this type of presentation, this type of view on how attacks are working and how you can defend against it, purple teaming courses are definitely a good one to look into. With that, I would like to thank you for your attention, and I will be happy to answer the questions who are here. I see that there's a number of questions open here. So let me see about the questions. So the question here, is Kali running on the same network as the Windows 01? Yes, in this case, Kali was running on the same network. So here we had Kali running on this environment, for example, to demonstrate if an attacker was already inside your network. If that's already inside your network, you could also say it doesn't need to be full Kali to run on your network. The example that I gave, you could also just open a listening port on a machine and do this entire attack or run this entire tooling or responder tooling from a single compromised machine to then do lateral movement to another machine there. Another question, is there any endpoint protection that will detect the poisoning? There is actually a tool, there's a project called Responder Guard. The person, you will be able to find it on GitHub. The person who created it, the name now escapes me. I think it's Bo Bullock who created this one. Responder Guard. That one will send out on a periodic basis, will send out like unexisting host names via and request an IP address for it via LLMNR and MBTNS. If it then gets a reply from someone, you will know that you have a responder type of attack going on within your environment itself. So that's definitely one that you could look into to run on your environment. When talking about outbound SMB, I indeed mean SMB connections going out to the internet. Absolutely, yes. Looking further here. For the malicious Word document, could an attack be modified for WebDAV for the remote source? I'm assuming yes, you could also use WebDAV for that one to download the attack, but I would need to test it to make sure that it actually fully works there. So I would need to verify and test that one. Is there any features in Word that can prevent the remote image load attack? So for the remote image load, it's a good question. We need to look at the exact feature that can be used to prevent that. Likely that you can do that using attack surface reduction that's present within Windows, but also that the exact one to be used, I would need to verify that one. With that, thanks a lot, everyone, for joining me here today. I hope you learned something, you can take something away from that. I see we're nicely nearing up to the end of the presentation. So thank you all for joining.
Yes, absolutely. And I did see there was one question about someone who had taken Security 560, which is our flagship pen testing course here at SANS, and asking if Security 599 was the next step. As the last slide that Michel had sort of indicates, so 599 is more split between defense and offense. So if you're looking to gain more information about cyber kill chain and about a very balanced approach, so if you're coming from the blue team or defender side, 599 is probably the appropriate next step. If you are coming from a penetration testing side or have already a significant background with cyber kill chain and defense, you might go straight into Security 699, which is more heavily on adversary emulation and is more heavily, you have to have more of a background with penetration understanding. I will say that on any of these courses, the course authors are linked directly on the course page. You can click through to those pages, and most of the time you can DM them directly on Twitter. Their emails are pretty readily available, and you can also join the Offensive Ops Discord that we have available. And we have channels for each of those classes in there. And if you ask there, the course authors check in there regularly, and you can interact with other instructors as well. So just wanted to cover that before we signed off here. Thank you very much, Michel, for bringing this content again. If you didn't see Michel's last webcast on persistence mechanisms, I definitely would check that out. There is an even older webcast on a similar topic as well. So quite a lot of resources out there. Michel, we very much appreciate you bringing this content to the community. To our listeners, thank you very much for joining us today. For a list of all upcoming and on-demand SANS webcasts, please visit sans.org/webcast. And until next time, we hope to see you again. Bye for now.
Yeah.